Interfaces are one of the most misunderstood constructs in Java and in many other programming languages. I talked about this in detail in the second part of my Ultimate Java course that is about 4 hours long. But let me explain it very briefly. An interface is a contract that specifies the capabilities that a class should provide. Let me give you a metaphor. Imagine you want to open a restaurant. You need a chef. It doesn't matter who the chef is, so you're not dependent on a particular chef. You're only dependent on someone who can perform the role of a chef, someone with certain capabilities. This is an example of a loosely coupled system. Now, I told you that an interface is a contract that specifies the capabilities that a class should provide. So in this example, we can represent the role of a chef with an interface and the actual chefs with classes that implement the chef interface. So this is the idea behind interfaces. With interfaces, we can build loosely coupled applications. Let me show you this in code. So let's say we want to build a tax calculator. Tax calculation is complex and the rules may change from one year to another. We can have a calculator for year 2019 and another for year 2020. Just like we can have different people filling the role of a chef at a restaurant, right? But what do all tax calculators have in common? They probably have a method called calculate tax. We can represent this with an interface. So in this package, let's add a new class. First, we change the kind to interface and call it tax calculator. So this is just a contract that specifies the methods that our calculator classes should implement. So here we add a method, float calculate tax. Note that we only have a method declaration. So we are terminating the statement with a semicolon. This method does not have a body. It doesn't have implementation. If we add curly braces here, we get a compilation error. So this interface is saying, hey, if you want to build a tax calculator class, that class should have a method with this signature, okay? Now let's add a real tax calculator in this project. So we add a new class. We call this tax calculator 2019. Now over here, we type implements tax calculator. Now we have a compilation error because we haven't implemented the calculate tax method in this class. We can put the caret over here, press Alt and Enter, and select implement methods. IntelliJ added the calculate tax method in our class. Now don't worry about this override. This is called an annotation. I talked about this in the second part of my Ultimate Java series. For now, all that matters is that this class has a method with this signature. So here we can return 1. Now let's create another calculator. So once again, we add a new class. We call it tax calculator 2020. Once again, we say implements tax calculator. Then Alt and Enter, implement methods. Beautiful. Now in year 2020, we can return 2. So we have 2 different implementations of this interface. Now in our application, instead of working with these concrete implementations, we should work with this interface. This is called programming to an interface. So anywhere we need a tax calculator in this program, we're going to work with this interface. For example, we can go back in the main class. Let's add a public static method. I made this static so we can call it directly from the main method, okay? Now this method should return a tax calculator. So here we're using our interface. Let's call it get calculator. For now, we're going to return a new tax calculator 2019. Now in our main method, we're going to call the get calculator method and store the result in a variable called calculator. So in this method, we have a dependency or coupling to this interface. Now this interface is very simple. It's very lightweight. All it has is a method called calculate tax. As long as we keep the signature of this method exactly as is, we're not going to have a breaking change. This is how we achieve loose coupling. So with this style of programming, if we go to our tax calculator 2019, and let's say add a new method here, public float calculate insurance. We have changed this class, but this change is not going to impact our main method over here because we're programming to an interface, not a concrete implementation. Now, if you have been paying close attention, you might say, but Mosh, over here, we are newing up a tax calculator 2019. So if you make any changes in this class has to be recompiled, and that means the main class should also be recompiled. That is true. But this is a very simple example to demonstrate this concept. In a real enterprise application, we're not going to write code like this. We use what we call a dependency injection framework that gives us real implementations of an interface. So in our code, we work with interfaces. Now, if this concept is new to you, don't worry, we're going to talk about this more and more throughout the course.